Good morning or good afternoon, depending on when you're watching this, or good evening. Maybe you're not seeing this till later, or whatever it might be. Before we get started, yesterday you were supposed to watch the Ed puzzle that was on lesson 1. It was just a short portion of it. And at the end of it, I assigned for you questions 3 and 4. In a moment, you're going to have a spot to enter those in. If you didn't do that, now's your chance. And if you did, great. And you won't be able to move on until you answer those questions, okay? That will essentially be how I check in your homework for lesson 1. That's an awful check mark. I don't like it. There we go. Okay. So today's lesson is going to look kind of familiar to some stuff from last year. But we're going to start to progress through equations a little bit more in depth than what you're used to. Our focus is to represent balanced hangers with equations, plural. And then we're going to be looking at adding or removing blocks from a hanger in order to keep them balanced. We start with a notice and wonder. Let's just take a minute to reflect on a notice and wonder and enter that into the prompt. Okay, so some things that you maybe noticed were that there are obviously 2 sets of socks. The pink ones are hanging balanced on the hanger. The blue ones are obviously not. You might wonder if these socks are the same size. Maybe there's something in this sock weighing it down. How much do they weigh? All of this is going to play a role into the types of questions we're going to be looking at today. So very similar to the warm-up, we're going to look, or the notice and wonder, we're going to look at this hanging block. And this picture represents a hanger that is balanced. It's telling us that both sides, the left side and the right side, weigh the same amount. Even though they don't have the same number of triangles and squares, they do weigh the same amount. Elena is going to take off 2 triangles from the left side and then 3 triangles off from the right side. Will the hanger still be in balance, or will it tip to one side? And if so, which side will it tip to? And we're going to focus on that explanation piece. Take a minute and go ahead and type in your response for that. Okay, so let's kind of think this through. I'm just going to reason through some components before I go through and think about what Elena did. So whenever I remove something from one side, I have to remove the same thing from the other side to keep it balanced. So if I take a square away, I have to take another square away from this side. If I take a triangle away, I have to take another triangle away from this side. If I take another triangle away, I have to take another triangle away from that side. That is essentially what is going to be keeping this balanced. You get to the end here and you can see that 2 squares is equal in weight to 3 triangles. So that just gives me some more information. 2 squares equals 3 triangles. So I'm going to actually erase my little markings and then let's kind of reason through what Elena did. So Elena goes through and she says, I'm going to take away 2 triangles off of the left side, and then I'm going to take away 3 triangles from the right side. There's no way that this is going to weigh the same amount on both the left and the right side because she didn't take equal amounts of triangles away from both sides. So what ends up happening when she does this? Well, because I've taken away more weight from this side, now the left side is going to be heavier, so it's going to tilt to the left. So now we go into this idea of what if a triangle weighs 1 gram? How much does a square weigh? Go ahead and see if you can figure that out. Okay, so here I'm going to now kind of go back and relabel some stuff. So I know that 1 triangle weighs 1 gram. I'm going to label all my triangles with a 1 gram. And since I don't know the weight of my squares, I'm going to give them a variable name. I'm going to call them all x. So on the left side of my equation, I have 3 x's And I have 1, 2. So 3x's plus 2. And on the right side, I have an x. And I have 1, 2, 3, 4, 5. Same idea though, when you solve an equation, you have to keep it balanced. So if I take 2 away from the left, I must take 2 away from the right. That leaves me with 3x equals x plus 3. Now, I've been emphasizing a ton to you guys about writing things algebraically. If you don't have this, write this down, okay? I know you can reason through and solve this, but as you progress in my class and the class you take next year, the equations get to be more complex and you need to have a strategy for organizing your work. All right, now we're going to take away one of my squares. I'm going to take a square away from the right side and a square away from the left side. So I'm going to show you, I'm taking 3x away here, and I'm going to take, oh, I'm sorry, shame on me, 1x, not 3x. Take 1x away here, and I took 1x away here. And I'm now left with the 2x's is equal to 3. So I know 2 squares is equal to 3 triangles. Now, obviously, in the picture, that doesn't make sense to split up 3 triangles in half, but numerically, when I divide, one of my x's is equal to 3 halves, which is equal to 1.5. So 1 square weighs 1.5. Hopefully you did okay with that. Just keeping in mind your success criteria is to represent balanced hangers with equations, which we just did, and add or remove blocks from a hanger and keep the hanger balanced. Okay, moving on to this next piece, and really it's the last component. How am I on time? 7 minutes in. I'm trying not to make it too long, but I'm doing my best. Okay, so now we're going to get more into this idea of equations a little bit. Go ahead and take a few minutes first on your own to find the weight of a square in hanger A and the weight of a pentagon in hanger B. You can reason through this in whatever way you want for this first part. Okay, so if you went ahead and did that, great. I'm not going to reveal the solution yet, but I am going to now focus on the equations. So what I would like you to do now, again, before I go through and reveal what this is going to look like, I'm going to challenge you now to write an equation to represent each of the hangers, and you'll have a spot to enter those in. All right, great. Now we're going to go through and really make sure that you have a solid understanding of what you did. So I'm going to go ahead and fill in everything I know. I know a triangle weighs 3 grams, so I have 3 and 3 and 3. And then circles weigh 6. 6, I think it's kind of hard to see the black, so let's use a different color. I will use red, even though circles are red. I don't know, yellow? That's hard. Okay, black it is. Sorry, guys. This is not important. Okay, 3 for a triangle. 3, 3, and then 6, 6, 6, 6, 6, 6, and 6. Okay, let's focus on hanger A first. Again, if I don't know the value of something, I'm giving it a variable. And on the left side, I have 1x plus 3 6's, so I have 18 plus another 3, 21. And on the right side, I'm going to set it equal to 1, 2, 3, 4, 5 x's plus 6. And again, the focus is make sure you write this algebraically. If you didn't do it now, this is your opportunity to make sure you understand it. All right, let's start taking things away from both sides. I'm going to take 1x away from the left and 1x away from the right. I'm left with 21 is equal to 4x's plus 6. You could take away as much or as little as you want at a time, but my goal is to obviously find the value of x. I'm going to now take away, let's see, 6 from the right, 6 from the left. So I have 21 minus 6 on this side. I'm running out of room a little bit. I'll just do this. Okay, so now I have, oops, let's write that in there. I'm left with 4x here. All right, and then 21 minus 6 is 15. There we go. And then now I could just divide these last four here that I'm highlighting. And I am left with this amount here. So I need to break this up and divide it into equal parts. And then I have the 4x's. So that's essentially what's happening. So you could leave this as a fraction. We could say 15 over 4. We could say 3 and 3/4. Those work. Okay, so that's the value of one of the squares on hanger A. Okay, on hanger B, since I have a different picture, I don't have squares, I'm going to use a different variable here. I'm going to call it y. And on the left side, I have 2 y's and 6 plus 6, which is 12. And on the right side, I also have 2 y's and I have 6 plus 3 plus 3, which is also 12. Okay, let's start balancing. I am going to take away 12, both of my 6's, from the left. And I'm going to take away the 12 on the right. Well, that's interesting because now I'm left with 2y on each side. Well, if I take away the 2 y's, I'm really just going to be left with 0. So let's make sense of this. What values could work for y? Well, let's say y is 5. Well, that will work perfectly fine. It'll keep it balanced. I'll have my 12 and I'll have 5 plus 5. And on the right side, I'll have 12 and 5 plus 5. That will keep it balanced. Let's try a different value. Let's say I had 2. On the left side, I'll have 12 plus 2 plus 2. On the right side, I'll still have my 12 here. That's the 12 I'm referencing that I just highlighted. And the y's, 2 and 2. It's going to keep it balanced. Let's try another number. I don't know, -4. 12, -4, -4. On the left, right side, 12, 2 -4s. It's going to keep it balanced. So any number will be true for y. All numbers are solutions. Yay. Okay, hopefully that makes sense. All right, I've been talking for a long time. Okay, let's see, what else do we got here? You could read through the lesson summary. I recommend you do that. It'll just go into a little bit more detail. But other than that, let's see, we are done. So I'm not going to give you a spot to type in your practice problems, but practice problems. And I don't have my book in front of me, the actual book, to see what they are. So you obviously know what the page is. I am navigating online right now to look to see. Bear with me. Luckily, I'm only doing this video one time. Cross my fingers until the end when I probably will realize there's no sound. Just sitting here by myself talking out loud is what it feels like right now. Okay. Practice problems, where are you? Let's see. All right, we are going to do numbers. This is your homework. If you didn't finish the video, that's your homework as well. Okay, practice problems. Let's see. How about it would help if I look at the right lesson? Okay, lesson 2. Practice problems. All right, I'm thinking we can do numbers. 1, 2, 3, 4, and you know what? 5 for good luck. All right. I'm sorry that this video is 15 minutes long. Hope you guys enjoy your day. Hope you made sense of it. I will see you tomorrow. I'm signing off.